the principle of mass conservation, whatever you say. So we are familiar with different conservation laws for conservation of mass, conservation of energy, conservation of momentums. Yep. So we actually need to understand it because many engineering devices actually works on this principle, the conservation of mass and energy principles, along with their linear momentum equations. So we must need to understand it. So you will see a lot of applications later on. So now, in general, if we think from physics and chemistry point of view, we can say that the mass of the system, if it is a if the system is closed, so the mass of the system, it will remain constant over a period of time. Like with the change of the time, the mass, it will not change inside the system. So what it says, you can not change the mass. So the quantity, it can neither be added or nor be removed, but the mass, it will be same. So some of you are familiar with the fountain, so you will see the water is coming in, out, and just going in. So it's continuously happening. So in general sense, what we can say, the mass conservation principle is it is just the input equal to the output. So whatever input you will provide, you will get an equal amount of output. So no change, as we cannot create the mass or the energy, or we cannot destroy it. This is the general scenario. You look here in these examples. If we do some experiment here, like the mass for this is 1.7 gram, this is 0.2 gram. So then when we're just making when the process is happening, we'll get let's say a new substance, we'll get an exact equal amount of mass. So for better understanding what I said, if it is a closed system, so let's say this is an arbitrary closed system, and this is actually the system boundary. So inside this system here, the mass inside this system, it will be always constant. Let's say mass is coming in, you are applying some heat energy, you are getting some work energy. It could be the case. So whatever thing is happening, the mass inside the system, it will be always constant. So what it means, you see, the mass inside the system is constant, it's not changing. That you can say, with respect to time, the mass is not changing. So that means d or dt, this is the rate of change of the mass inside the system. It is actually zero. It's constant. It's when the mass inside the system is constant, that means the rate of change of the mass inside the system, it is zero. So in other words, what I said earlier, we can say the mass in and the mass out, it will be just the rate of change of the mass of the total control volume. So here Mn is the rate of change of the mass. This is this is the mass is coming in, this is mass is going out, and this is the rate of change of the mass within the control volume. So what we said is conservation mass is, in general sense, you can say like the input is equal to the output. We'll solve some problems.